Smart technology has become an expectation in our electronic devices for almost all applications. However, the holy grail of interoperability among different smart home products remains a challenge. With the industry discussing adoption of the Matter protocol to fix this problem, how can engineers begin to understand this exciting new open source protocol and ensure their embedded designs are built to migrate towards it? We've heard in the last 6 to 9 months a lot more about a protocol that's been discussed for a while called Matter, and the promises that that's bringing to embedded engineers in allowing that interoperability for even the least technical users, and how that's going to help us in our designs going forward. Today I have the privilege of speaking with Declan Starr, the Director of Applications Marketing for Smart Home at Infineon, and someone that's already spent a tremendous amount of time with the Matter protocol to give us a few insights on exactly where this protocol is going and what we as embedded engineers can be doing with those designs to be prepared for this migration to Matter. Declan, thanks so much for being with me today on The Current.
Hey, good morning, Todd. Thank you for having me. Pleasure.
Absolutely. Absolutely. We really appreciate it. So let's start kind of, I guess, from the beginning when it comes to Matter. It's obviously a very new protocol. I think many of us are trying to read up on it and understand it and see exactly where this is going. But can you kind of give me a little idea of what exactly Matter is and the promise that it's kind of offering to the market over time?
Yeah. I mean, Matter, which, confusingly was renamed in the middle of its development, was previously known as Project Chip. Its aim is to be a single unified application layer based connectivity standard. And that standard then is designed to enable developers, right, to connect, build reliable yet secure IoT ecosystems, but then also to increase compatibility among smart home and smart building devices, right? So
Right.
At its heart, it's an application layer based protocol which operates on top of IPv6. And then given that it operates on top of IPv6, virtually any IPv6 bearing network is compatible. So with that spec, as long as it supports several of the core, the kind of standard IPv6 standards. But however, I guess the initial standard version is focused on supporting kind of Ethernet, Wi-Fi, and the thread link layers first. Hence, the spec is kind of restricted to these link layers at the start.
Right. And so we've seen some of this in the past. I mean, I think, going back all the way to like 802.15.4 in the early 2000s and then Zigbee and then that trying to become, turning into Z-Wave, and nothing against those protocols and what happened, but I don't think, at least from my perspective, it ever reached the full level of adoption that I had hoped to see, I think, from Z-Wave when I was doing a lot of design with it way back when. What do you think makes Matter different and is going to help with the adoption of it, as opposed to what we saw with some of those previous standards?
Oh yeah, for sure. I mean, this is not the first time we've heard the words, a standard to harmonize, like the Lord of the Rings quote, one ring to bind them all. I think, in my opinion, the major differences with Matter are probably threefold. I think participation. I think today, there's over 280 plus companies, and it's growing fast. They're actively involved, and helping to define and shape the different applications and segments that will be compatible with the Matter fabric. So today, the big focus is on smart home, but you can look at who's sitting on the board of from some of these companies, and they're not your traditional smart home companies. You've the likes of Schneider and Siemens, who are typically smart building. So you can see even these guys see this as a long-term play where, we kick it off in smart home, but it catches fire, it becomes popular, and then it becomes the standard into smart building. And we have a lot of, already in version 1.0 of the spec, you have a lot of what I'll call crossover applications, crossover from smart home to smart building applications, such as smart thermostats, as an example, that basically will help that migration. So participation is number one. I think architecture, to me, is number two. From the outset, basically the CSA have taken the approach, a security-focused approach, and they've based the whole system around kind of industry standard security standards like PKI and blockchain. So basically, fundamentally, very, very secure. And then the third thing I think which is super important, which is what the The other, like the Z-Wave push and the Open Thread push, is they have now all of the large ecosystem guys are on board with Matter. And that means, hey, your smartphone talks Matter today, your smart TV, smart speakers, and your IP internet providers. They're all on board, and they're all already have released firmware over their updates. So, and I think and in automatic adoption, right? So November the 3rd, they officially launched Matter in Amsterdam. Basically, on November 3rd, they pushed a firmware over their update to all of these TVs and speakers, and so basically you have Matter Fabric in your home today, right? So
Right.
this is not like a Wi-Fi 4 to Wi-Fi 5 or Wi-Fi 5 to Wi-Fi 6 adoption where we talk about it, but we have to wait for the access point guys to get their first products out there, and then there's a lag while we wait for the products to come. This is instantaneous. It exists. Matter is probably in 90% of people's homes today.
Right. And that's to me what I think is so exciting about it is, like you said, the board is so huge. The people involved in creating the standard is so enormous. You have the consumer side represented by all those large companies that you mentioned for home automation, and a lot of the other large companies like Google involved in having conversations. You've got the semiconductor companies like Infineon involved heavily in making sure they understand the standard. So, and then you've got all the Z-Waves and all those other companies that are responsible for the communication protocols we already use that have been involved as well. So you kind of have that the entire network and every single piece of the puzzle there to build something that has, I think, a real chance of being highly successful. And I think, again, that's why we're having this conversation. We as embedded engineers have to start thinking about how we design our systems to maximize the utilization of it. Even if maybe our we only think a small percentage of our customer base is going to use it today, our system may be sitting at home a year from now, 2 years from now, 3 years from now, and to your point, need that update so that it can work on that Matter protocol. So with that, what are the considerations that we as embedded engineers need to be taking as we're designing a system today so that we can be a little forward thinking such that the hardware doesn't need to be changed out and the system can just take a firmware update so that it then is compliant with Matter?
Yeah, so basically a few considerations if I was a hardware engineer that I would take into point is, as we already discussed briefly, at this point Matter communicates over Ethernet, Wi-Fi, and Thread 802.15.4 only. Mm-hmm. But who's to say, CSA, as you said, might add support for other protocols later. So I think it's important, as you said, to have that mindset of future-proofing your products, right? And that requires a certain amount of maybe overhead from a flash and RAM and resource usage. But I think it's worth it in the long run if you can OTA this stuff as it develops. BLE, as we know, is only used for commissioning, so that's another important consideration, right? It's there to help you add a new device onto the Matter ecosystem or the Matter fabric. And then if you're today communicating over a different protocol, be it Zigbee, Z-Wave, or sub-gig, then you need to be your devices need to be bridged into that ecosystem, into that Matter ecosystem. We have already seen some bridge updates from some of the big ecosystem guys like IKEA, for their blinds and lights. We've also seen Philips Hue come out with a bridge update, and basically that enables them to grandfather these otherwise non-Matter compliant products, Zigbee lights or Z-Wave thermostats or sub-gig sensors. It allows them to grandfather those existing products into the Matter fabric. But I think that's I always think of it as there's going to be a phased approach. I think phase one is people are going to update the bridges and they're not going to immediately run through and refresh all of the end nodes to be directly Matter compatible. The phase one will be we'll update the bridges, get everything in, see how it grandfathered into the system, and then ultimately phase two will be that their future products will turn into the customer will probably require that they turn into Matter end nodes. By that I mean that they're individually addressable, right? That you no longer have to go through a hub, that's plugged in somewhere in your home, right? And the reason I say that, and the reason I think that will be the requirement, is because people are going to harmonize on the ecosystem that they choose. Do they want, maybe they want to be in the IKEA ecosystem? Are they, hey, they're big Google fans, or they're big Apple fans, or they're Amazon fans, right? So they're going to harmonize on an ecosystem, and then you're going to want, the products to work as well as possible on any ecosystem. And in my mind, that drives the need that the end nodes themselves, the light bulbs, the switches, the thermostats, they all become Matter compatible end nodes, not requiring a bridge.
Right. Gotcha. So maybe let's take it a step deeper and get a little more specific about what Infineon is doing in this realm. I know it was at your October Tech event, a couple months ago now, in San Francisco, or San Jose, I guess it was. I got a chance to spend a little bit of time with some of your Matter team and got to see some of that working. So can you speak a little more specifically about what Infineon in particular is doing in terms of creating hardware for these Matter-built devices, and also what kind of firmware, software tools are you guys developing to make it as easy as possible on embedded engineers to integrate Infineon products into a Matter-based system?
Yeah, it's a great question. So, given what I previously talked about, that Matter came as a firmware over-the-air update, and there's 300 million smart speakers in the world out there, and the majority of those kind of speak Matter over Wi-Fi. Infineon, we focus first on releasing our Matter over Wi-Fi solution, and that's basically we've launched that this quarter, and it's based on, as you know, because Matter is an application layer, the actual Matter application layer will run on the host. So in this case, we're running it on our PSOC 6, which is our dual core microcontroller, ultra low power, very popular in battery operated IoT devices. It's a dual core, so it has an M0 and an M4, and then we've basically paired that microcontroller up with we call them our 4300 series, the Wi-Fi Bluetooth combo devices. So this covers basically, there's a low power 11N option with the 43439. There's a ultra low power 11N, 11AC, 20 megahertz friendly option with the 43012. And then if you want full blown 11AC, where we also have support for the 4373 family. And we basically,
I hate to interrupt, but just I think an important point there is, because I think that's critical, is the fact that you're looking at combo devices with the Wi-Fi and the Bluetooth, because to your point, the Bluetooth is going to be used for the pairing, even if it's not used for the main application. You need that Bluetooth there. I think for a lot of design engineers, I know as I work with different companies, their kind of expectations, if I buy the Wi-Fi module, I kind of should get the Bluetooth for free, whether that's fair or not. That's kind of what it is, and I think that's a great product for it.
Yeah, for sure. And then basically, realizing that Matter already exists in the home, our focus has been on the Matter over Wi-Fi solution, and then basically we've taken this let's call them this chipset. We've taken this chipset through the Matter pre-compliance certification, right? So and that was successful. So that's kind of our way of telling our customers, hey, if you choose this particular chipset, we guarantee you Matter compliance, and we also we guarantee you a faster time to market. And then we've basically taken Matter and integrated it into our tool chain. So our IDE is it's Modus Toolbox, and basically that is now harmonized, and you can go online, download it. You'll find Matter over Wi-Fi code examples for stuff like Smart Lock. So, and then we've FAE training modules and all of this stuff on our Infineon.com/Matter, and you'll find all of this material that points you and gets you up and running, because we know this is new for everybody, and we're trying to minimize the burden and at least get you quickly developing with it while you go towards creating that first Matter compatible product.
Right. Brilliant.
And then I guess what's coming in future. Sorry to cut across. What's coming in future is our Matter over Thread solution. As you said, we have a Matter ecosystem demo where we're showing our Matter over Wi-Fi, working with Matter over Wi-Fi Smart Lock, working with the Matter over Thread lighting solution, and also we've taken some of our novel sensing technology, like our 60 gig radar sensor, and we've turned that into a fancy occupancy sensor that also works over Wi-Fi. But then what's also coming is we're working on our matter over thread solution, and we'll have some updates later in the year about sampling and availability on that. And then also because of matter, it's all based around security. There's and something that the hardware engineer has to take into account is this needs to get a matter particular certificate into the device somehow, a matter identity securely. So depending on, it has to happen on the manufacturing flow, or to ease that, we're also working on a kind of a security with our edge secure element products that would pre-configure all your matter certificates, and so we could ship you from our factory, your particular matter credentials and matter SKU, and basically ease the burden of you to not having to have a HSM or a secure manufacturing facility, because we know this is a big change for people that haven't dealt or haven't done secure products using PKI infrastructure before, that this is going to be a heavy lift for them.
Right. And you kind of already hit my next question, which is, what are the things that we as engineers need to take into consideration when it comes to security? It seems like that's already built in quite a bit, not just into the protocol, but the hardware that you guys are actually rolling out right now.
Yeah, basically, all told, Matter includes like over 10 substantial new security features, all the way from like secure unicast and multicast communications through like fine-grained access control, and then more security features will be added as needed. Right? This is a living document, a living protocol, and security has been a high priority for Matter from the start.
I think that's critical, and I think we all as engineers are trying to figure out exactly how we need to do that, and is it worth the extra design effort? Is it worth the extra cost to implement that? And the fact that's already kind of baked into Matter, I think, is absolutely huge, and something that we as as engineers have got to always take more into consideration than we certainly were 10 years ago. Is exactly how we're going to secure our wireless systems in particular, to make sure that it's not a weakness in anybody's overall network.
Yeah, correct. I think an interesting development is, Matter is an open ecosystem, right? So if you let's take the example of home security. If you're a home security guy, they have been a closed ecosystem traditionally, right? They've used proprietary technologies to talk among their sensors, and each different home security vendor has used a proprietary standard in a lot of cases. So now how does this work in Matter? And I think one potential way of creating, let's say, a preferred Matter network within that Matter fabric is through the use of secure elements. Saying, okay, I'm now this is part of the home security system, and I see they have a Matter occupancy sensor that's not from us. It's possible that hey, we see that it has a hardware, it has a secure element. You can have some kind of, you can give it a higher level priority over a random sensor that maybe has a different level or a lower level of security.
Right. Okay, so you just don't give it the same level of access if it hasn't given you the correct key, and proven that.
Or you don't give it the same level of priority. If it detects something, then maybe you use it as a backup source to confirm that something has happened, versus it's the main guy that you use to go and call the fire brigade or call the police or reach out to some security services.
That makes sense. So for sure. So, if I'm developing my first Matter-based platform, obviously we said it's open source. What are the steps that I would need to take to get it approved as a Matter device? Are there steps in that, given that it's open source, to be able to put that on my box to say this is Matter compliant?
Yeah. I think the CSA have done a pretty good job here. They basically, as I said, it's important to remember that every Matter end device needs to be certified by the CSA.
Right.
And they're going to keep a ledger, basically an online repository of of all of these certified Matter products. But they put together a very well defined process to guide device manufacturers step by step through the process. So
Okay.
it starts off, of course, with you have to become a member of CSA, and you have to request a manufacturer or a vendor ID. Who are
Okay.
you in CSA? So you get an identifier. Then you basically select, what transport options are required. Are you making a product that's over Wi-Fi, over Thread, over both, over Wi-Fi, Thread, and Ethernet? So you select. Then you basically, depending on where you're going to manufacture or what makes most sense to you geographically, you choose a design house or a test house. And that test
Okay.
house, if you go on the CSA website, they have a link of test partners. So ultimately, they're going to be the ones that will test your final product to say that it complies to all of the, all of the CSA or the Matter requirements. Um, then basically and then, as I said, the fact that semiconductor vendors like Infineon have already taken their chipsets through this pre-compliance process means that you're kind of, this is they've already pipe cleaned the flow for you on this particular chipset, right? So basically, going to the test house, won't be a 5 week effort. It should be, a few days effort, right? That's the
Should be
intent.
pretty quick.
Um,
Okay.
and then basically, once your product is ready, you work with the test house. They check it for compliance. They guarantee, uh, they give you, if it's successful test completion, then you submit an application to the CSA for certification. After product certification, you'll receive a certificate declaration, which is like a blob file from them. And, then they'll allow you to use, Matter compliance. You can stick the Matter label on the box, and you also now will have a certified product record that, as I said, goes into this online distributed compliance ledger of certified
Okay.
Matter devices.
Okay. All right. So great. So yeah, it's great to hear that it's already so well defined. I assume, from a cost standpoint of actually go through the certification process, I'm assuming you obviously are going to have a cost associated with the test houses. Is there anything that from the actually getting that license outside of just the cost of testing that's required?
No, I mean there's a small cost involved to become a member of CSA and get your unique
Right.
identity. I think it's like $2,000.
Okay. Okay.
I haven't got a good handle yet on the test cost. I'm sure working with the test houses, depending on the number of products and the amount of time, I'm sure that's a variable. So
It's
I
going
don't
to
want
vary from
I don't want to
everything.
throw out a
Sure.
number and be way off.
Sure.
But yeah, the process is pretty streamlined. The fact that people have done pre-compliance means that it's kind of like UL Class B cert. It should be a matter of getting the certifier in there, running through the test suites, and you maybe have exceptions of tests that are passing or failing that maybe don't apply to this particular product, and going through all of those steps.
Excellent, excellent. That's incredibly informative, and I think something that we're all considering as we're trying to adopt the protocol and to build systems that are going to work within the protocol framework. I think it's incredibly exciting where this is going and how it's going to have a huge impact on everything that we do on a day-to-day basis. So
Yeah,
glad
yeah,
to see
it's
this all
amazing. I
coming
mean,
together.
I'm not sure if you attended CES, but
Yeah,
I mean, Matter was everywhere at CES as
everywhere.
expected, right? It
Yeah,
got launched in November. You expect the hype for CSS's first big comeback after the pandemic. But what I guess what was even surprising for me was I was seeing products that are not yet, we'll say, not yet applications that would be considered Matter compliant, right? They're not covered in
right.
version 1.0 of the spec, but we're seeing products way outside smart home, like EV charging,
Oh yeah,
all already hinting at Matter compatibility. So again, I think
great.
it kind of builds that story that a lot of other industries, smart building, automotive, are already looking at Matter as potentially the harmonizer of this kind of complicated space. Everybody talks about the smart grid and electrification and digitization,
Yeah.
but for all of this stuff to happen, everything it has to speak a common language, and perhaps Matter could be that common language.
Yeah, yeah. It's there seems to be a lot of momentum to your point. There's no doubt in Las Vegas at CES back in early January, it was there. It was there like crazy, and it's exciting to see this protocol really hitting a point where there could be critical mass down the road for this to be what we're all looking at, and it's something that even people that aren't technical know the term Matter, and how that's actually helping their products work within their home the way they want them to. So incredibly exciting stuff. So, Declan, thank you so much for the time and for all the information. This is absolutely incredible. I think we're all looking for these kinds of primers on exactly what we need to be doing with this new and expanding protocol. And I'm sure we'll continue to have much more in-depth conversations as Matter, as all of us are starting to get much more familiar with it over time. And I do think that's where things are going. Thanks also to our audience. We appreciate you so much for joining us here at Future Electronics at the Current. If you have questions or needs in regards to a Matter-based platform that you're looking at designing, or any other embedded system platform that you're looking at designing, we would absolutely love to get our engineering team or myself to help you out with what you're working on. Please reach out to us at Shaping the Future, one word, Shaping the Future at futureelectronics.com. And we'd be happy to talk with you, meet with you, and get you the information that you need, samples that you need to be successful in your product development. Again, Declan, thanks so much for your time, and all the best. We'll talk to you next time.
Hey, Todd, pleasure talking to you. Look forward to the next one.
Absolutely.